So hi everyone. My name is Kaan, and I'm working at the Ethereum Foundation. And today I'll be talking about Sourcify and how we enable human-friendly contract interactions with Sourcify. At Sourcify, we do open source code verification, and we have a public repository of verified contracts on IPFS. I'll be giving a top-down look to what we want to achieve as our end goal, but then I'll come back and bottom-up build up how we achieve this. And before that, Croatia actually has been home to Sourcify. So it was built by guys at Sharp Labs. So shout out to them. And yeah, this is inherently going to be a technical talk, but I'll try to keep it as simple as possible so that everyone will understand. So bear with me. Okay, so what's wrong with today's UX in the Web3? So many things, but one thing that bothers me a lot, I guess it bothers you as well, is this. So like when you want to sign a transaction, you see something like this. I know this has been changed recently for many wallets. They kind of decode things, but this is more or less the everyday life in Web3. That's what we would like to call YOLO signing. So you just YOLO the signature and hope for the best that you are doing the right thing. So what we want to achieve is actually from this to something more human-friendly, something that hopefully will look like this. And how can we do this? What can we do to achieve this? There are two sides of the problem. First, the things you can do as a smart contract developer, as well as things you can do as a wallet developer. So let's dive into what you can do as smart contract developer. The first thing you can do is use NatSpec documentation. So what is NatSpec documentation? It is part of the Solidity documentation, Solidity languages specification. And it's called Ethereum Natural Language Specification Format. So how does it look like? If you're familiar with JSDoc, JavaScript documentation, it looks similar. So we have the title, author, these parameters. Let's look at this in an example. I like looking at examples better instead of direct documentation. So we have a Solidity function here called swap owner. And here we have the NatSpec documentation in the comment field. So we have the developer documentation. We have the user documentation explaining the user what it does in plain terms, and documentation for the parameters. So another nice feature of the NatSpec is it allows dynamic expressions. So the fields you see here for the user documentation notice, and we have the variables, address variables, old owner, new owner. So it allows filling these fields dynamically when showing this to the user. What I mean by that is this documentation can become this when you're interacting with the contract. And even better, maybe we can use something like this instead of an address. Okay, but where is the user doc? Where is the dev doc? Like, how do I find it? It's in Solidity contract metadata. Is there anyone familiar with what Solidity contract metadata is? One person. That's fine. That's one of the things why I'm here. I want to talk about this. So it is also part of the Solidity documentation, and it is the JSON file generated by the Solidity compiler which contains metadata. Surprise. What I mean by metadata. So the metadata contains the ABI, the user doc, the compilation info, and the source file info. These are the main four fields. And the first two is concerned with the question how to interact with the contract, the ABI and the user documentation. And the second two is about how to reproduce a contract recompilation. So how can we do the exact same thing, exact compilation again? And the file looks like this. As I said, it's a JSON file. You have the compiler, you have the output settings, compilation settings, and the sources. And there we have the user doc and dev doc. We found it. And if we open the user doc, then we can see the swap owner user documentation replaces the new owner, the old owner with the new owner. Okay, but where is the metadata? We found the user doc, but where is the metadata then? So there are several ways to find out. The straightforward way is to use the Solidity compiler. If you give the metadata flag to the Solidity compiler, it will output the metadata file. If you are using Truffle, for example, if you are using frameworks, you compile, then you go to build contracts and the contracts JSON. There you find the metadata. If you are using Hardhat, recently with Hardhat 028, you can find them in the contracts output in this large build file. Okay, so you've been a good developer, you documented your code. Now it's the second step, source code verification on Sourcify. But what is source code verification? What do I mean by that? So let's say you have a contract at this address, right? And I tell you that this is the source code of this contract. What is it? How do you know? If I just give you some code, how do you know this is actually the address, the source code of this contract? So what you do, if you're familiar with this, you just type the address in the Etherscan and see the contract, green tick, and it's all good, right? Okay, that's what we do today. But what does this mean? What's behind this? So say you are compiling your contract and there are multiple files, multiple Solidity files in the contract. You have contract files as well as a compilation setting. And remember what I talked about in the metadata. So we recompiled that. But what I talked in metadata is these last two fields helps us reproduce a contract compilation, right? This is where it comes handy. So we take these Solidity files, we take the compiler settings, and we refeed this into a compiler, the correct version of the compiler. Then this will output a bytecode that will run the smart contract. If you are not familiar, the Solidity contracts get compiled into a bytecode, which is similar to an assembly code. And that will run on the EVM. So we have the bytecode. Then what we do is we have a contract on the blockchain. Then we pull the bytecode of this contract and see if there's a match here. And in Sourcify, we define two types of matches. One is the partial match, where the bytecodes match. And the second type that is different in our case is the full or perfect match, where bytecodes plus the metadata of the contracts match. So a contract bytecode looks like this, and the bytecode usually have a special field at the end of the bytecode. This is appended by the Solidity compiler, and this contains the hash of the metadata, which enables the full matches. This is encoded in CBOR encoding, and it has the hash of the metadata. I will break down this a bit further. So that means if you have a partial match, you only have the normal field, normal area, let's say. And if you have a perfect match, you have this bytecode plus the metadata field at the end. And this cryptographically guarantees us that what you see is actually what has been put by the developer. Like it's byte by byte the same thing deployed on the blockchain. Like it doesn't even differ in a byte, in a comment, in a variable name. It's exactly the same. And how does it work? So when you compile a contract, the Solidity files are also hashed. This is done by the compiler itself. And the compiler takes the hashes of the files and it puts the hashes in the metadata file. Remember, there was a sources field in the metadata file, and these hashes are embedded in the metadata file. Then, as well as the other sources have their own fields. Then the hash of this metadata file is taken, which in this case an IPFS hash, and this hash is encoded here. And if there's a match, then the IPFS hashes also match. That's what we call a full match. So what happens when something changes in one of the files? So we have, let's say we change the variable name, we added a comment, we added a space, anything, and we have a different file now. Obviously, the hash of the file will change. Then the hash in the metadata will change. And at the end, the hash of this file will also change. So this field will also change at the end of the bytecode. This will be different. And this time, the one you recompiled won't be completely matching the one you pulled from the blockchain. So these last fields will be different. That's what we call a partial match. And if you are curious about this, we have a nice tool to play around with. That's called Playground. You can go there. We have some example contracts. You can also put any contract you want and see how it's decoded, the things I've shown you like before. Yeah, it will decode the fields of IPFS, Solidity version, etc. Okay, but like metadata hash, bytecode, something, what are you talking about? Just tell me what I want to do. What do I have to do? I want to be a good developer. I want to be more transparent. Anyway, so you go to Sourcify and do source code verification. How do you do that? So we have an UI. You just go to sourcify.dev, and we have a verifier there. You can give us the files, the address, and where the contract is, in which chain the contract is, and we can verify for you. We have an API. You can make use of our API, and we have other endpoints as well that you can explore. You can check out the documentation page to learn more. We also have some integration and tooling. For example, the hardhat deploy plugin. And with that, you can just say, after deploying your contract, you can just say hardhat network mainnet Sourcify, then it will verify it for you. We have also a Remix plugin. After deploying your contracts via Remix, you can verify on Remix. And we also do automatic verification. That's what we also call the monitor. The monitor catches the contract creations on Ethereum mainnet and testnets. We are listening to mainnet and the testnets right now only. And it tries to fetch the metadata and source files from IPFS. Remember, we can find the IPFS hash at the end of the bytecode. There we can get the metadata file if it is published. And it tries to automatically verify the whole contract. So that means, actually, you don't have to go to Sourcify and verify it. You just have to publish and pin the metadata and the source files on IPFS. So if you publish on IPFS, we verify for you. But with a side note, only on Ethereum mainnet and testnets. And this has to be already published around when the contract is deployed. Like we have kind of a buffer around 5 minutes, but before deploying or at the time of deploying, it should be published. So right now we have a contract repository of verified contracts, and this is both served over HTTP and IPFS. We have over 1 million small files. It's around 11 gigabytes right now, and we are also serving this over IPNS. It's updated regularly, and you can access over IPNS with this. But if you don't want to parse this string, you can just go to our website and check out the footer to access it over a IPFS gateway. Okay, so what you can do as a wallet developer then. Now this is related to the first part of the metadata, which is how to interact with the contract. The below part we talked about. This is now about how to interact with the contract information which is found in the metadata file. So what you do is you go to our repo, you get the chain ID, the address, and fetch the metadata of the contract, right? No. You can do that, but it does not give you the full power of content addressing through IPFS. What I mean by that is, so you have the contract bytecode. Let's roll back. And this section has the IPFS hash of the metadata file, right? The metadata JSON file. So you can decode this section, get the IPFS hash, and you can pull the metadata file from IPFS if it's already published. That will give you the nice property of content addressing. So you can access the file with hashes instead of asking a server somewhere else, you can know what you get, the file is exactly the same file you are asking for. That's the property of content addressing. Yeah, so you got the metadata file, then you decode the ABI, decode via the ABI, and populate the NatSpec comments for the function. So as a wallet, you got the metadata, and the user was calling a function. You just get the ABI and the NatSpec comments and decode it. And hopefully, at the end of the day, you can show something like this instead of some hex strings. There is one more thing to these main two pillars. What you can do as a regular user or a developer. So you're not a wallet developer, you're not a smart contract developer, and you're asking me what I can do to help you out. So build tools. We need a lot of tooling, a lot of integrations, and this is the main thing, one of the overall goals of this project, to integrate this into the development pipeline to be able to make this as seamless as possible. So we are welcoming any contributions for integrations or plugins or extensions. You can pin and replicate the IPFS repository that we are serving right now. Raise awareness for contract metadata, spread the word, follow us. And if you are interested, if this sounds interesting for you, we are hiring. You can check out the job ad here, or if you don't have an access now, you can just check out our Twitter. We already posted the job ad on our Twitter as well. So thank you, and I'll be happy to answer questions if there are any.
Thank you. So are there any issues regarding like the visibility of the source code when you're working with proxies or daemons, for example?
Yeah, so right now we don't have proxy support. I know, for example, Etherscan has. You can separately verify the proxy contract and the contract, the child contract as well. You can separately verify them, but we don't look into the contract and say, oh, this is a proxy file, because also we are not a block explorer, so we don't directly provide you like what happened with this contract and how to interact with this contract, but this can be done by a wallet, for example. A wallet can easily see this is a proxy and act accordingly.
Perfect, thank you.
If there are no other questions, thank you.